Hello everyone. Today we will see what are cyber physical systems. So cyber physical systems, these are advanced systems where the computational elements such as software and the data processing, these are tightly integrated, okay, with the physical components like sensors, actuators and machinery in order to interact and to control the real world processes. And these systems, these are designed to monitor, control or optimize the physical operations through computational power. Now in CPS systems, that is CPS, cyber physical systems, uh, the sensors will collect the data from the physical world, and the actuators, these will enable the systems to make the changes or adjustments in the real life, and the computational side processes this information, making decisions, predictions or automating the actions. So some of the examples of CPS are medical instruments, okay, then in medical instruments, devices like pacemakers or robotic surgery systems will monitor the health and make real-time adjustments. Then you have transportation vehicles like driving cars, where the sensors and the algorithms control the vehicles based on real-time data. And you have defense systems where the smart weapons or the surveillance systems that process the data to make the operational decisions. And the next is robotic equipment, where the industrial robots, okay, which are used in the manufacturing, then these are used to interact with their environment and adapt to changes in the production line. And the last is process monitoring and the factory automation, where the systems that monitor the industrial processes adjust the machines for efficiency and even predict the failures. These are the examples of the CPS. Now, some key characteristics of the CPS are embedded systems, communication, and control. So, embedded systems, these have the computational capabilities that interact with the physical world, and communication, these often involve the networks that allow the components to communicate. For example, you have IoT or the wireless connections here. And third is the control, which can control or influence any physical systems based on the computational data. And these are the key components of the CPS system, okay, that is CPS. The first is the physical process. It is also called as the plant, okay. And this is the real world system which you want to control or monitor. And it could be anything from a robot or an industrial machine, a vehicle or a biological system, okay. That is nothing but a physical process, or even it is called as a plant. For example, you will be having a factory assembly line, and you will another example is an autonomous vehicle or a heart monitoring system. These all are the physical processes. Then second is sensors. So sensors, these will collect the data from the physical process, and these will convert it into the digital signals that the computational components can process. And these sensors can measure a very these can measure a variety of physical parameters like temperature, speed, pressure, position, etc. And the examples are temperature sensor, then you have pressure sensors, proximity sensors, and GPS. You have n number of sensors. Then next is actuators, okay. Here, actuators, okay. So actuators, these are the components that take the computational output, use them to influence or control the physical process, and they convert the digital signal back into the physical actions. Examples are motors, then you have walls, then robotic arms, then you have steering mechanisms in self-driving cars. The next is controller. Actually, actuators should come here and controller should come here. Then you have uh, after sensors you have actuators, then you have controller. So Controller, this is where the actual computation or the decision making and control algorithms reside. And here, the controller, it processes the sensor data, applies logic and generates commands that are sent to the actuators in order to modify the behavior of the physical systems. For example, you have microcontrollers, embedded processors, or even cloud-based servers in the complex systems. Then next is the communication network. Here in CPS, it involves communication between the different components. This network allows for the transmission of sensor data, commands, or status updates between various physical devices and the computational elements. For example, you have wired or wireless communication. That is, you may have Wi-Fi, Bluetooth, etc. Then last is the user interface. It is the optional. Here, some CPS may have a user interface which allows the humans to interact with the system, and the interface might display the system status, allow manual control, or show real-time data from the sensors. For example, user interface examples of user interface are touch screen dashboards. You have control panels or web apps for remote. And one of the example for this CPS is autonomous vehicle, okay, where the physical process will be a car or a robot, that is the vehicle itself. Then sensors will be the cameras or the speed sensors or GPS. These will gather the data on the environment, then vehicle speed, obstacles, etc. And controller, the onboard computer running AI algorithms to interpret sensor data and make driving decisions. Then you may be having actuators, that is motors, steering, brakes, and other systems that physically control the car's movement. And the communication network will involve the wireless network, allowing the car to interact with the vehicles, then traffic systems or the cloud. And you may have the user interface, that is the dashboard or a mobile app that the vehicle owners or operator uses to monitor the vehicle's health and make manual adjustments or interact with the navigation. Okay, so this is about the cyber physical systems. Then next is the differences between the embedded systems and the CPS. So the differences between these lie primarily in their complexity, scale, and functionality, but both involve the integration of hardware and the software. The CPS, it is more advanced and networked evolution of embedded systems, and we'll see the differences based upon the definition. Okay, these features we have compared for considered for the differences, that is definition, scope, resources, then task force, main issues, and the examples. So coming to the definition, here embedded systems, these are dedicated computer systems, okay, computing systems designed to perform a specific task or set of tasks within a device, and these are self-contained and focus on a particular applications. For example, you will be having a microwave ovens control system or a washing machines embedded controller. Whereas cyber physical systems, these refer to integrated systems where both physical and the computational components, these will interact and communicate with each other. And these systems include not only the embedded components but also the networked connections between them, and make them capable of handling complex distributed interactive tasks. Okay, and example for this is autonomous vehicles, smart grids, or the industrial automation system. So next we will consider the resources. Okay, so here scope is these are typically confined to a single device, and these are confined to networked set of devices or the systems. Then you have resources and tasks. So here in embedded systems, These systems are generally limited, like they have limited sources, and that is the processing power, memory and the energy. These will be limited, and these are designed to perform a small set of tasks with high efficiency. And these systems are optimized for their specific applications, often with tight constraints on the computation and the storage. Whereas CPS, these are not constrained by the resources. Okay. And CPS tend to be more powerful with access to more computational resources, storage, and network capabilities, and they often have to perform more complex tasks involving the data decisions, involving the data processing and the decision making and coordination across the multiple components. Okay, and the main issues here are here you'll be having a real-time response, and the reliability is more, and in cyber physical systems it is about the timing, concurrency, and the synchronization. Okay, so here example is a digital thermostat, and here the example is the smart grid. Next we'll come to features of the CPS. So the CPS, these are designed to integrate, that is cyber and the physical. Cyber, it refers to the computational, and physical refers to the real world components in a way that allows them to interact in real time. Okay, so the first feature is the reactive computation. Here CPS system must react to changes in their environment in the real time, and here under this you have ongoing interaction, that is the CPS continually interacts with the physical world, and this interaction is typically continuous, and it happens as long as the system is running. Coming to the observed inputs and outputs, these systems operate by observing the inputs from the sensors and generating the outputs that drive the actuators. Okay, like observing the input from sensors means you will be having the temperature sensor, pressure sensor, speed sensor. Okay, so these will get the inputs from these type of sensors, and the outputs are influenced by the sequence of inputs they receive over the time. Example here is a smart thermostat that will continuously monitors the room temperature and adjust the heating of the cooling system. Monitoring the room temperature will be the input, and adjusting the heat or the cooling system will be the output based on the user settings. Okay, next is the concurrency. Concurrency, it involves multiple processes running at the same time, all working towards a common goal. Okay, what is it? It is multiple processes running at the same time, and all are working towards a common goal. So the key points here are concurrent processes, that is multiple tasks or processes in the CPS may run simultaneously, such as gathering the sensor data, then processing the data, and sending control commands to the actuators. The next is the exchange of information, that is processes need to exchange the data synchronously or asynchronously to collaborate and achieve the desired outcomes. Okay, for example, one process might detect an anomaly, and another process might respond by adjusting the system's operation. So here example is autonomous vehicle, that is in an autonomous vehicle the sensor data, that is it may be a camera, it is processed continuously while the vehicle's navigation and the control system adjust the car's trajectory in parallel, both the systems exchanging information in real time. Okay, so next is the feedback control of the physical world. Here it incorporate feedback control systems that adjust the physical world based on the real data. Okay, and the key points are feedback loop, that is the sensors continuously monitor the environment and they will provide feedback to the controller, which then makes adjustments through the actuators. This is the basic mechanism of control in the CPS. And example here is a self-driving car where the sensors such as cameras, these will feed data to the control system, which processes the data to make the decisions about steering, then speed, and braking system. So in hybrid control systems, some CPSs, these use hybrid control system combining the continuous control, that is the adjusting the vehicle speed, with discrete control, that is deciding when to change the lanes. And these systems can handle complex tasks that require both the types of control mechanisms. Then next is the real-time computation. So here in many CPS applications, these require time sensitive computations to ensure that the operations are performed within the strict timing constraints. Okay, here the key points are time sensitive operations, which involves the real time decisions where delays can result in poor performance or even the system failure. And operations such as resource allocation, then task scheduling, and coordination must happen within specific time windows. And example here is the industrial robotic system, where the robot's action must be coordinated in real time to avoid the collision, with precise timing to execute tasks like pick and place the operations. And you have the coordination and resource allocation, where these tasks must be carefully managed to ensure efficient and safe operation in the environments where multiple systems are interacting. And the last is safety critical applications, which are used in safety critical environments where failures can have severe consequences. And here the key points are precise modeling and the validation, that is given the potential risks involved, the CPSs in safety critical applications require careful modeling, then simulation and validation before deployment to ensure that they function correctly and safely. Okay, that is you have to test. Then example is medical device. Okay, so in a medical device such as pacemaker or the robotic surgery system, the system must be thoroughly tested in order to ensure that it behaves predictably and safely under all the conditions. And in case of failure, the consequences could be life threatening. So the safety and the reliability, that is these are designed with the redundancies, real time monitoring, and false fail safes to ensure continuous operation even in the event of partial system failures. Now these are the applications of the CPS in the healthcare system. So first is here the first one is highly accurate medical devices and the systems. So uh, the CPSs, these will enable the development of high precision medical devices which can perform complex tasks with a high degree of accuracy. And these devices, these will integrate sensors and computational systems, and these can process and interpret the patient data in the real time. Examples are smart pacemakers, which are used these devices monitor the heart rate and adjust the pacing automatically and responding to the patient's needs. Then you have robotic surgery, where systems like the Da Vinci surgical system, which uses the real-time data from the sensors and the cameras, and it allows the surgeons to perform minimally invasive surgery with extreme precision. And second is image guided surgery and therapy, that is these will utilize the CPS in order to provide the real time uh, high resolution imaging combined with precision computational control in order to guide the surgeons during the operation or the therapies. Okay, and these will integrate medical imaging techniques like MRI, CT scans, then you have ultrasounds with the robotic systems in order to enhance the accuracy of the procedures. Examples here are the robotic assisted surgery, that is the CPS enabled robotic surgery tools use the live images such as the CT or the MRI scans in order to guide the surgical instruments with the incredible precision, improving the outcomes in complex surgeries like neurosurgery. Then you have orthopedics or the cancer treatment. And another example is the radiation therapy, where the CPS is used in image guided radiation therapy, where the system adjusts the radiation beam in the real time in order to target the tumors. Then the next is control of fluid flow. So here, many medical applications, this requires the precise control of fluid flow, whether for drug delivery or the biology analysis, that is biological analysis. And CPS can regulate the pumps, okay, walls and the fluid channels in the real time, ensuring that accurate administration of fuels or maintaining specific conditions for experiments. And here the examples are the infusion pumps. These are the devices that deliver the precise amounts of medication or the fluids to a patient, adjusting the flow rate based on the real-time feedback from the sensors. And you have dialysis machines. These are the automated dialysis systems which uses the sensors and the actuators to carefully manage the flow of fluids during the filtration process. And these will mimic the kidney function in patients with renal failure. Okay, that is about the control of fluid flow. Then you have intelligent operating theaters and the hospitals. This CPS, this can be used to create the intelligent environments within the operating theaters and hospitals that optimize the workflows, enhance the patient's care, and improve the safety. And the integration of the sensors, IoT devices, and real-time monitoring systems, these will make hospitals smarter and help the doctors to manage patients more effectively and improve the overall care efficiency. For example, you have smart operating rooms where the CPS can manage the lighting, then temperature, equipment, and even the patient positioning based on the real-time feedback during the surgery. And it can also assist in ensuring sterile environments and automatically tracking the instruments or the tools to prevent the errors. And then you have hospital resource management. These intelligent systems can monitor the patient with parameters like bed occupancy, staff availability, and equipment usage. Okay. Then last you have the cognition and the neuroscience based systems. Here the CPS based systems that are grounded in cognitive science and the neuroscience offer innovative treatments and assistive technologies for patients. These systems include technologies like brain machine interfaces, then robotic therapies, and neuro like you will be having neuroprosthetics that connect human cognition with the machines, okay, enabling better functionality and the rehabilitation. So the examples here are brain machine interfaces. These systems will allow the individuals with paralysis or severe motor impairments in order to control the devices. That is, you may use here robotic arms or the communication devices using their brain signals. Okay, with the help of the brain signals, these arms and all will be robotic arms will be moving. There will be movement in the robotic arms, and the CPS, these will translate the brain activity into the commands that control the external devices. And you have other examples such as robotic therapy, and you have exoskeletons. Okay, these are some other examples of the cognition and neuroscience based systems. Then next you have application of CPS in the transportation. So first is the infrastructure based transportation, CPS. And here this involves the intelligent infrastructure which supports transportation systems using the CPS in order to enhance the monitoring, like and controlling and management of the transportation networks. And these include the traffic lights, cameras, then road sensors and traffic management systems that are connected and can communicate with vehicles and the central control systems. Okay. And next, second is vehicle infrastructure coordinated CPS. So these involves systems where vehicles communicate with the infrastructure such as the traffic lights or the traffic signals, road signs, or the city-wide traffic management systems in order to optimize the traffic flow and enhance safety and improve overall efficiency. And these systems use vehicle to infrastructure, okay, that is termed as V2I communication in order to exchange the data about the traffic conditions and the vehicle status in the real time. So here the examples are the transit signal priority, where the public transit systems like buses and the vehicles can get priority at the traffic signals in order to reduce the delays, improving the punctuality. And if a bus is running late, then the traffic light can turn green in order to allow it to pass through the intersection. And you have emergency vehicle prioritization, like your the this ambulance, okay. And for that there will be queue warning systems, okay. Then you have vehicle based transportation CPS, where the CPS, it focuses on the enhancing the safety, health and the functionality of the individual vehicles using the sensors, then communication systems and the real time data processing. And these systems help in monitoring the vehicle's condition and provide proximity alerts for safety and improve their driver assistance. So examples are the private proximity detection, where the CPS in vehicles can use the sensors like radar cameras in order to detect the objects or the vehicles around the car and issue a warning, and take correct like actions in order to prevent the collisions, okay. And other examples are vehicle health monitoring, you have autonomous driving. So next is applications of CPS in the smart grids.